Welcome. Dear learner, we are discussing about the physical techniques for synthesis of a nanomaterial. Friends, in this lecture, we have to see what is a molecular beam epitaxy. So in physical techniques of synthesis of a nanomaterial, in previous lecture, we discussed about what is a physical vapor deposition. That is thermal evaporation, in which the target material is heated so that it is converted into the vapor form, and this vapor is deposited on a glass substrate. Then second technique is a sputtering technique, then pulse laser deposition technique and ion beam deposition techniques. In this lecture, we have to see what is molecular beam epitaxy. What is a molecular beam epitaxy? What is the advantages of a molecular beam epitaxy? And what are the disadvantages of a molecular beam epitaxy? After attending this lecture, the student will be understand about what is a molecular beam epitaxy, how the thin film can be prepared by using this method, advantages of this method and disadvantages of this method. Question is arises, what is epitaxy? The growth or attempt growth of a single crystal layer upon single crystal substrate. That is, the single crystal layer is deposited on a single crystal substrate. There are different types of epitaxy. First is the homoepitaxy, in which the growth of a same crystal. That is, when silicon is deposited on a silicon crystal, then the epitaxy is the homoepitaxy. Second is a heteroepitaxy, in which the growth of a different crystal on a substrate. When the germanium is deposited on the silicon substrate, then the epitaxy is a heteroepitaxy. Then vapor phase epitaxy, in which the growth, epitaxial growth within low pressure or high vacuum environment. The pressure is very low, and this pressure is about 10 raised to minus 10 torr. The molecular beam epitaxy is the experimental technique utilized for layer by layer growth of a thin film of a various quantum material. The molecular beam epitaxy or the growth take place in ultra high vacuum environment. The molecular beam epitaxy experiment setup consists of two or more Bunsen effusion cell, or we can say that K cell, which are located at the bottom of a ultra high vacuum chamber, and these K cells are aligned toward the center of a chamber where sample holder with substrate is located. Each individual K cell contains a different element in ultra pure solid form, that is elemental 99.99% cerium and bismuth, which can be used in a thin film synthesis. This is the experimental setup. The K cells are fixed at the bottom and aligned toward the center where the substrate is located. The substrate is placed in a sample holder or hold in a sample holder. Now this sample holder can be rotated. The sample holder can be rotated by using magnetic manipulator, or we can say that the sample holder can be rotated by using stepper motor, and the rotation is about 1 or 2 rotation per minute. Then there is a reflection high energy electron diffraction gun, that is RHEED gun, from which the electrons are emitted, and these electrons are incident on a substrate, which is used to control the deposition of a thin film over the substrate or layer over the substrate, which is also used to control the thickness of the thin film. Then there is a turbo pump, which is used to create the vacuum. Turbo pump through which the low vacuum is created. Okay, it is about 10 raised to minus 10 torr. So the K cell located at the bottom of a ultra high vacuum chamber and aligned toward the center of the chamber, heating of a K cell to appropriate temperature. When the K cell is heated at an appropriate temperature until the element in each cell reach to the sublimation point, then the suitors are open. At the sublimation points, the suitors are open and physical vapor from the K cell diffuse through the chamber until it reach to the substrate. That is, the physical vapors from the K cells are goes toward the substrate and deposited over the substrate. Then the RHEED means reflection high energy electron diffraction. The characterized the sample in situ during the growth. Then there is a ultra high vacuum, which is created by using turbo pump. Then sample holder with substrate, and then this sample holder with substrate can be rotated and attached to the magnetic manipulator, which can be rotated during the growth. The process of a molecular beam epitaxy growth start by heating K cell. First, K cell is heated at an appropriate temperature until the element in each cell reach to the sublimation point. When the element reach to the sublimation point, then the suitors are open and physical vapor from each K cell diffuse through the chamber until it reach to the substrate where it get deposited and the thin film get formed. The final composition and stoichiometry of a firmware depend on the temperature and substrate atomic structure of the substrate, as well as the flux ratio of individual components reaching the substrate. For more uniform growth, substrate can be continuously rotated at a low rotation speed. It is about 1 rotation or 2 rotation per minute. Substrate can be rotated by utilizing a stepper motor attached to the magnetic manipulator. The characterize the sample in situ during the growth. We use reflection high energy electron diffraction, that is RHEED. The electron emitted from the reflection high energy electron diffraction and gun incident at a very low angle with respect to the sample surface are diffracted. The electrons from this RHEED gun incident on the substrate and it get diffracted. A resulting diffraction pattern is observed on a screen. This pattern can reveal. It gives the information about quality of the thin surface. Film thickness down to a single monolayer. That is, it gives the quality of a thin film and film thickness. The growth process is performed in ultra high vacuum environment creating by continuous pumping by turbo pump. We use the turbo pump which is used to create high vacuum environment. The rate of deposition is kept very low and substrate temperature is rather high. In order to achieve sufficient mobility of the elements on the substrate and then layer by layer growth to obtain nanostructure or high purity thin film. The sample holder with substrate is attached to the magnetic manipulator which can be rotated during the growth. K-cell are attached to the bottom of the chamber pointing toward the substrate. Selective openings of the suitors on each K-cell ensure the growth using only sufficient element. All these things we know. Characterization of a substrate and the thin film continuously monitored during the growth and performed by RHEED. Then the techniques like reflected high energy electron diffraction is incorporated to monitor high crystallinity of the growing film. The film which is deposited on a glass substrate is not amorphous. It shows the high crystallinity and which can be performed by using the reflection high energy electron diffraction, which is also used to control the which gives the good quality thin film. Okay, and the thickness which is used to monitor the thickness of a thin film. Then there are some advantages of this molecular beam epitaxy. First, it is widely used to manufacture semiconductor devices, including it is used to manufacture the transistor. Then it is also used to fabricate diodes and metal oxide field effect transistor. And also it is used to manufacture the laser, which is used to read optical dices such as CDs and DVDs. The laser which is used to read CD and DVD can be manufactured by using molecular beam epitaxy. Then this technique can be used to deposit elemental or compound quantum dots, quantum walls, quantum wires in a very controlled manner. Then high degree of purity is achieved during this process because we use ultra high vacuum and so that there is a high degree of purity. There are some disadvantages of this method. First disadvantage, for overall perfect and pure film, it is necessary to maintain very low pressure of order of 10 raised to minus 10 torr, which is a slightly difficult because we use ultra high vacuum, and it is very difficult to maintain this very low pressure. This process is very expensive as compared to the chemical vapor deposition process. The growth rate in a molecular beam epitaxy process is about 0.01 to 0.3 gram per minute, which is a very small compared to the growth rate of 1 micrometer per minute in a chemical vapor deposition process. So in this lecture we discuss what is the molecular beam epitaxy. Then the experimental setup of this molecular beam epitaxy. In experimental setup there is a ultra high vacuum which is created by the turbo pump. Then K cell which are mounted at the bottom and aligned toward the substrate which is located at the center. The substrate can be rotated by using stepper motor. Substrate is held in a sample holder or substrate holder, and this can be rotated, and the rotation is about 1 or 2 rotation per minute. Then reflection high energy electron, the high energy electron diffraction process is there. The electrons are incident on the substrate, so that which is used to control the purity and the thickness of a thin film. So very simple process, molecular beam epitaxy. Now you have some assignment. First, explain the molecular beam epitaxy in detail. What is epitaxy? State and what is epitaxy? State and define its type. Second, state advantages and disadvantages of a molecular beam epitaxy. Then send this assignment on Google Classroom. In next lecture, we have to see what is electric arc method. Electric arc method is also used for deposition to prepare the thin